Hello, welcome to this part. So in this part, we are going to discuss about the method of joint and the basis on which it depends. So now, the concept of method of joint is based on the fact that if the entire truss is in equilibrium, then each of its joints will also be in equilibrium. So if the entire truss is in equilibrium, then all of its joint will also be in equilibrium. Now, what is the meaning of this statement? Well, if all the joints are in equilibrium, then we can apply equations of the equilibrium there to analyze it. So that is why this is the answer to this statement, that we can apply the equation of equilibrium. Now, if the free body diagram of each joint is drawn, the force equilibrium equations can then be used to obtain the member force acting on each joint, which is what I just said. So if we take the example of this truss, so this is the free body diagram of this truss, and these are the reaction component AX and AY. AY is the vertical reaction at A point, and AX is the horizontal reaction on this uh, truss point A, and another reaction is at point E, which is only the vertical reaction. So this is the example of simply supported truss. Now when I say simply supported, it means one end of the truss is hinged, which means the support is hinged support, and on the other end there is a roller support. So roller support offer only one reaction, which is uh, shown here, which is EY, and hinge connection offers two reaction. One is horizontal reaction and the second one is the vertical reaction. Now if we take the example of this truss, so now what we can do is we can take any of the joint and we can apply equation of equilibrium to find out the force in that particular member. For example, if I take the example of joint B, this one, so I will make the free body diagram of joint B. So in this case, you can see this is the FBD of B. So this is point B, and force in member BD, I am referring this as FBD. So force in member BD. Similarly, force in member BC, it will be FBC. Similarly, force in member BA, it will be FBA. Now, what is the nature of this force? Whether it is compressive, whether it is tensile, that remains to be seen, because that is what we are going to calculate. But initially, we have to assume the sense. For example, in the FBD, we have assumed the sense of force as, I mean, this sense is away from the joint. Similarly, FBC sense is also away from the joint. FBA force sense is also away from the joint. So all forces are pointing away from the joint. So that is what we have assumed. So now based on this sense, this assumption, if we analyze and if we get the value of FBD, FBC, FBA positive, that means the sense that we have assumed are correct. If the value is negative, it means the sense is opposite. So by chance FBD value, this value is negative, it means the sense will be towards the joint. So that is what we can correct. So we will see this in detail when we will be solving the numericals. So we can apply the equation of equilibrium, and because as I said this is a two force member, we can apply force equilibrium equation. We will not applying the moment equation here. Why? Because as I said, all the joints are pin jointed, and in pin joint moment is free, which means moment is permitted. So that is why we will not apply this equation. We will be applying only two equation. Okay, so with these two equations we can find out the forces in two members. Similarly, if we look at other, I mean if we look at free body diagram of other joints also, so you can see here, this is the free body diagram of A. So in the A joint you can see the two reactions and and the force in member CA and force in member BA, they are being shown. So basically, in method of joint, if we have to find out member in all the, I mean, if we have to find out force in all the members, we will take joint one by one and we will apply force equilibrium equations, and then we can find out the magnitude of the force in the member. Now we will see what is the process to use this method of joint. So that is what I have discussed here. So first of all, first step would be to draw a free body diagram of the truss showing the loads, probable direction of the reactions at each support. So in the numerical, we will be given a truss. So first of all, we have to make the free body diagram of that truss, which will be showing the reactions, which will be showing the loads. Then in second step, we can calculate the reactions, and reactions will be calculated in the same manner as we have done in case of beams in the previous lecture. So in the same manner, we will be finding reactions in the truss. Third step would be visually identify zero force member. Now, in the truss, sometimes we add some member to provide the stability. Now, we have added that member to provide the stability to the truss, but it may not be necessary that that member will be experiencing some force. So the member which is not experiencing any force, those member are known as zero force member. So third step would be to identify visually zero force member. Now there are some indication like how can we visually identify zero force member in a truss. So for that I have given an indication here. It says at a joint, if two or more members meet at 90°, generally at 90°, then the member opposite to which no force, no reaction, no member exists will have a zero force, and the same is marked on member as shown in figure. Well, this is an example of the truss. So in the truss, you can see there are member FE, FB, FA, member AB, then member EC, ED, DC. Now in this truss, if we have to visually identify the zero force member, how do we identify that? So based on this statement, it says at a joint if two or more member meet at generally at 90°, then member opposite to which no force, no reaction, no member exists. So if we take joint F, so in the joint F, you can see opposite to this member FE. This is the joint for member FE. So opposite to this will be left hand side. So there is a support, and support will offer a reaction. So opposite to this member Fe, there is a reactive force. So which means member Fe cannot be a zero force member. Similarly, if we talk about the member FB will cannot be a zero force member because it is also attached with the support and which is offering the reaction. Similarly, if we talk about the member FA, well, you can see member FA is connected with member AB at joint A. Now, if we consider joint A, then you can see member AB, opposite to the member AB, there is no force, there is no member. Okay, I will make this joint separately. Like this is joint A and this is member AB. So opposite to this will be left hand side. So you can see there is no force, no reaction, no member. Similarly, if we talk about the member FA like this, So second member is this one, which is AF. Now opposite to AF, so opposite to AF will be downward side. So in the downward also there is no force, no reaction, no member. So this is a perfect candidate of zero force member. This is also meeting at 90 degree. So we generally consider that joint which is at 90 degree. So in that case, member AF and member AB will be zero force member. Similarly, if we consider joint D, although joint D is not at 90 degree, but visually we can see here that member ED and DC, they are just provided in this truss for the stability purpose only. Member ED and DC will not be experiencing any force because opposite, if we consider joint D, then opposite to ED, there is no force. Similarly, if we consider member CD, so opposite to CD will be upward side. Again, there is no force or member. So member ED and DC will also be zero force member. And ultimately, we can say that only these 5 members are actually carrying this load. Other 4 member, this one, and this one, they are just provided here for the stability purpose only. They are not actually experiencing any force. Now, by chance, if you are not able to visually identify zero force member, in that case, what you will do is you will be following the method of joint process, and at last, in the calculation, you will find member AF is having zero force, member AB is having zero force. So basically, to make calculation work small, we generally do this visualization. So that is the indication for showing the zero force member. Similarly, if we take another example, say in this case, this is the another truss, and if we have to find out zero force member, then how do we find out? First of all, consider joint D. Now, why I have taken joint D? Because you can see this member, there is an angle 90 degree, there is an angle 90 degree. So these member CD, DE and DF, they are meeting at 90 degree. So if I consider joint D, say joint D, this one, so this member is DE, this member is DC, and this member is DF. So these angle is 90 degree. So now if I consider this member, so opposite to this member, there is this member. So that is why this member and this member, they will not be zero force member because they are opposite to each other. But if I talk about the third member, this one, so opposite to this, there is no force, and there is no member. So this member will be zero force member. Similarly, if we talk about joint G, so in the joint G, HG is opposite to GF. So member HG and GF, they will not be zero force member. But when we talk about member CG, now opposite side of CG member will be downward side. So in the downward, there is no force, no member. So CG is also a zero force member. So this is how we can visually identify zero force member. If we take another example, like the case of this truss. So in this truss also, you can see if we consider joint H. So on the joint H, you can see member AH and HG, they are meeting at 90 degree, but opposite to member AH. So opposite to member H will be this side. Opposite to member GH will be this side. So there is no force, no member opposite to them. So that is why member AH and HG, they will also be considered as zero force member. Similarly, if we talk about uh, joint D, in this case also, the member is meeting at 90 degree, and they will also be, there is also no force here, you can see opposite to member ED, no force, opposite to member CD, no force. So that is why member CD and ED will also be considered as zero force member. So I hope now things are clear to you. Our next step would be to assume the sense of forces in unknown member. So for example, if there is a truss, say this is the truss. So fourth step would be, so okay, I will repeat again the steps. First step is to make the free body diagram. So free body diagram of this truss would be like this. So this is the hinge support. So it will be having two reactions, and this is roller support. So it will be having one reaction. Say it is having one force, say 10 kilonewton. Okay. So this is 10 kilonewton. So in this case, second step would be to find out the reaction. Third step to identify the visually zero force member. So there will be no zero force member in this truss. Now fourth is to assume the sense of force. We have to assume the sense of force in each member. For example, if this is the member, we have to assume whether this member is in tension or this member is in compression. So we will just assume that. So for example, if I assume that this inclined member will be in compression. Now, in case of compression, if I consider this joint, so along this joint, there will be this member, this member. So I have to show the sense of the force in this member. So if it is compression, if I'm considering this as compression, then the arrow will be pointing towards the joint. By chance, if I consider this member to be in tension, so in that case, the arrow will be away from the joint. So this is how we will be assuming the sense of the forces. And after analysis, if the value is positive, then our assumption will be correct. If the value is not positive, it is negative, then we will say that our assumption is incorrect. And sense would be opposite to that, what we have assumed. Fifth would be, now in the fifth step, it says choose a joint which has not more than two members. So in a truss, we will choose that joint first, which will be having two unknown member. So again, if I make a joint, make a truss, say this is a truss. So in this truss, I will choose that joint which will be having at least, I mean, not more than two unknown member. So I can choose this joint because in this joint, these two members are connecting. So this member is having unknown. This member is also unknown. So I can take this joint. But I cannot take this joint. Why? Because this joint is having four members. This one, this one, this one, and this one. So all four are unknown. So that is why I cannot take this joint first. I will take the joint which is having members, forces, not more than two. Unknown forces, not more than two. And sixth step is we have to repeat the same step, same process that we have done in fifth step until the forces in all the member is calculated. So these are the procedure that we are going to follow to analyze a truss. So in the next part, we will take an example of truss and we will see how we analyze it. Thank you.